This lesson will explain how to determine the best measure of center and variability based on whether a data set is symmetric or skewed. If the data is symmetric, we should use the mean for the measure of center and the mean absolute deviation for the measure of variability. If the data is skewed or has outliers, we should use the median for the measure of center and the interquartile range for the measure of variability. And now let's look at an example. Here we have data that represents household incomes in thousands. We have 35, 38, 40, 42, 45, 48, and 100. Notice this 100 is much larger than most of the data, and therefore the data is skewed to the right or has an outlier, and therefore we should use the median for the measure of center and the interquartile range for the variability. Let's begin by determining the median. The data values are already ordered from least to greatest, and we have a total of 7 data values, indicating the data value in the fourth position would be the median. Notice there are 3 values above 42 and 3 values below 42. In order to find the interquartile range, we'll also need to determine quartile 1 and quartile 3. Recall quartile 1 is a median of the lower half of the data set, and quartile 3 is the median of the upper half of the data set. Because there are 3 values below 42, notice 38 would be the median of the lower half, and therefore 38 is quartile 1, and 48 is quartile 3. So now we know the median is 42, quartile 1 is 38, quartile 3 is 48. The interquartile range is Q3 minus Q1. The interquartile range is 10. So again, because the data is skewed, or because we have an outlier, the best measure of center is the median of 42, and the best measure of variability is the interquartile range, which is 10. We'll take a look at a second example in the next lesson. I hope you found this helpful.